welcome to the session on transformation of equations. If alpha 1, alpha 2, etc., alpha n are the n roots of the equation f of x is equal to 0, the process of finding the equation whose roots are phi of alpha 1, comma phi of alpha 2, etc., phi of alpha n, where phi is a specified function, is known as a transformation of the equation f of x is equal to 0. To find the equation whose roots are phi of alpha 1, phi of alpha 2, etc., phi of alpha n, we proceed as follows. If x represents a typical root of f of x is equal to 0 and y represents the corresponding root of the transformed equation that is required to be found, then y is equal to phi of x, which is called the transformation relation. To find the required equation, that is the equation satisfied by y, we have to eliminate x between the equations f of x is equal to 0 and y is equal to phi of x. We have to eliminate x between these two equations f of x is equal to 0 and y is equal to phi of x. Here we shall discuss some standard transformations. First one is, if alpha 1, alpha 2, etc., alpha n are the n roots of the equation f of x is equal to a naught x raised to n plus a1 x raised to n minus 1 plus etc. plus a n minus 1 x plus a n is equal to 0. Let us find the equation whose roots are m into alpha 1, m into alpha 2, etc., m into alpha n. Here the transformation relation is y is equal to m into x. Eliminating x between this equation y equal to m into x and this equation f of x equal to 0. The required equation is f of y by m is equal to 0. From here we can write x is equal to y by m. Substituting x equal to y by m in this equation, in this first equation, we will get a naught into y by m all raised to n, that is y raised to n divided by m raised to n, plus a1 into next term is y raised to n minus 1 divided by m raised to n minus 1 plus etc. plus a n minus 1 into y by m plus a n is equal to 0. That is a naught y raised to n plus m into a1 y raised to n minus 1 plus m square into a2 y raised to n minus 2 plus etc. plus m raised to n minus 1 into a n minus 1 y plus m raised to n a n is equal to 0. That is we multiply all the terms by m raised to n, we will get this equation. Therefore, the required equation is obtained by multiplying the successive coefficients a naught, a1, a2, etc., a n by m raised to 0, that is 1, m raised to 1, m square, etc., m raised to n. In particular, if we put m is equal to minus 1, we find the equation whose roots are minus alpha 1, minus alpha 2, etc., minus alpha n. The required equation in this case will be a naught y raised to n. If m equal to minus 1, the corresponding equation will become a naught y raised to n minus a1 y raised to n minus 1 plus a2 y raised to n minus 2 minus etc. plus minus 1 raised to n into a n is equal to 0. Therefore, to get the equation whose roots are minus alpha 1, minus alpha 2 etc. minus alpha n, the signs of the second, fourth, sixth etc. coefficients are changed. When this rule is applied, the missing term, if any, should be assumed to have 0 coefficients. This is the first transformation. The second one is, if alpha 1, alpha 2 etc. alpha n are the roots of the equation f of x is equal to a naught x raised to n plus a 1 x raised to n minus 1 plus etc. plus a n minus 1 x plus a n is equal to 0. Let us find the equation whose roots are alpha 1 minus h, alpha 2 minus h etc. alpha n minus h. This transformation is referred to as the diminishing the roots. The transformation relation in this case is y is equal to x minus h. Therefore, the transformed equation is f of y plus h is equal to 0. From this, we can write x is equal to y plus h. Therefore, the transformed equation is of the form f of y plus h is equal to 0. That is a naught into y plus h all raised to n plus a 1 into y plus h raised to n minus 1 plus etc. plus a n minus 1 into y plus h plus a n is equal to 0. That is a naught y raised to n plus n into a naught into h plus a 1 into y raised to n minus 1 plus etc. is equal to 0. That is b naught y raised to n plus b 1 y raised to n minus 1 plus etc. plus b n minus 1 y plus b n is equal to 0. Where b naught is a naught, b 1 is equal to n into a naught into h plus a 1 and so on. That is b naught equal to a naught, b 1 equal to n a naught h plus a 1 etc. If the term containing y raised to n minus 1 is to be absent in the transformed equation, then we will get n a naught h plus a 1 is equal to 0. That is h is equal to minus a 1 divided by n into a naught. Thus, if we want to remove the second term, that is the term in y raised to n minus 1 from the transformed equation, the roots of the given equation must be diminished by h is equal to minus a 1 divided by n into a naught. Consider f of y plus h, which is identically equal to b naught y raised to n plus b 1 y raised to n minus 1 plus etc. plus b n minus 1 y plus b n. Putting y is equal to x minus h, we will get y equal to x minus h. Then we will get f of x is equal to b naught into x minus h raised to n plus b 1 into x minus h raised to n minus 1 plus b n minus 1 into x minus h plus bn. From this, it is clear that bn, the coefficients bn, bn minus 1, bn minus 2, etc., are the successive remainders obtained when f of x is successively divided by x minus h. The successive remainders bn, bn minus 1, bn minus 2, etc., that is the coefficients of the transformed equation in the reverse order, are easily obtained by resorting to synthetic division. Note that to increase the roots of an equation by h, we have to decrease the roots by minus h. Now, the third transformation is, if alpha 1, alpha 2, etc., alpha n are the roots of the equation f of x is equal to a naught x raised to n plus a 1 x raised to n minus 1 plus etc. plus a n minus 1 x plus a n is equal to 0, then we can find the equation whose roots are 1 by alpha 1, 1 by alpha 2, etc., 1 by alpha n. The transformation relation in this case is y is equal to 1 by x. Eliminating x between the equations f of x is equal to 0 and y is equal to 1 by x, the transformed equation will be of the form f of 1 by y is equal to 0. From this we can write x is equal to 1 by y. Therefore, on putting x is equal to 1 by y, we will get the equation as a naught into 1 by y raised to n plus a 1 into 1 by y raised to n minus 1 plus etc. plus a n minus 1 into 1 by y plus a n is equal to 0. That is, a n y raised to n multiplying throughout by y raised to n, we will get a n y raised to n plus a n minus 1 y raised to n minus 1 plus etc. plus a 1 y raised to a 1 into y plus a naught equal to 0. Note that the coefficients of the transformed equation are those of the given equation written in the reverse order. Now, consider an example. If alpha, beta and gamma, alpha, beta and gamma are the three roots of the cubic equation x cube minus p x square plus q x minus r equal to 0. Then form the equation whose roots are we have to form some equations. First one is whose roots are beta plus gamma minus 2 alpha, gamma plus alpha minus 2 beta and alpha plus beta minus 2 gamma. And second one is we want to form the equation whose roots are alpha divided by beta plus gamma minus alpha, beta divided by gamma plus alpha minus beta, and third one is gamma divided by alpha plus beta minus gamma. Consider the first case. We have to form an equation whose roots are beta plus gamma minus 2 alpha, gamma plus alpha minus 2 beta, and third one is alpha plus beta minus 2 gamma, where alpha, beta and gamma are the three roots of the given equation x cube minus p x square plus q x minus r is equal to 0. Consider the root beta plus gamma minus 2 alpha. This can be written as alpha plus beta plus gamma minus 3 alpha, because beta plus gamma is here and in the right hand side this also. Alpha minus 3 alpha is minus 2 alpha. Since alpha, beta and gamma are the roots of this given equation, we can write alpha plus beta plus gamma as S1. S1 is minus A1 divided by A0. In this case, A1 is P, therefore minus A1 means minus of minus P, that is P divided by A0 is 1, that is equal to P. Therefore, we can write here P minus 3 alpha. Similarly, for this root gamma plus alpha minus 2 beta, which is equal to, this can be written as alpha plus beta plus gamma minus 3 beta. Which is equal to P minus 3 beta. And this third one is alpha plus beta minus 2 gamma, like this we can write alpha plus beta plus gamma minus 3 gamma, that is P minus 3 gamma. So, we have to form the equation whose roots are P minus 3 alpha, P minus 3 beta and P minus 3 gamma. Therefore, we can use the transformation relation as y is equal to P minus 3x. We use this relation y is equal to P minus 3x. From this, we can write x is equal to 1 by 3 into P minus y. Using this in the given equation, we will get the required equation as x cube, that is 1 by 3 into P minus y the whole cube, that is 1 by 27 into P minus y the whole cube, minus P into x square, that is minus P into x square means 1 by 3 into P minus y the whole square, that is 1 by 9 into P minus y the whole square, plus qx, that is q into 1 by 3 into P minus y, minus r is equal to 0. That is, from this we can write P minus y the whole cube minus 3P into P minus y whole square, multiplying all the terms by 27, we will get P minus y the whole cube minus 3 into P minus y square plus 9 into q into P minus y minus 27r is equal to 0. That is, on expanding, we will get minus y cube plus 3p minus 3p into y square plus minus 3p square plus 6p square minus 9q into y plus p cube minus 3p cube plus 9pq minus 27r is equal to 0. Expanding and combining the grouping the terms having y cube, y square, y and the terms independent of y, we will get this equation, that is y cube. From this we can write y cube plus this will become 0. From here we can write 9q minus 3p square. Here 6p square minus 3p square is 3p square. We multiplying all the terms by minus 1 on both sides. We will get y cube plus 9q minus 3p square into y, plus from this we will obtain 2p cube minus 9p cube plus 27r is equal to 0, which is the required equation whose roots are beta plus gamma minus 2 alpha, gamma plus alpha minus 2 beta and alpha plus beta minus 2 gamma. Now, consider the second case. We want to form the equation whose roots are alpha by beta plus gamma minus alpha, beta by gamma plus alpha minus beta and gamma by alpha plus beta minus gamma. Consider the first one. Alpha divided by beta plus gamma minus alpha, which can be written as alpha divided by, in the denominator we add alpha and subtract the same. Therefore, we can write alpha plus beta plus gamma, this is gamma, minus 2 alpha, which is equal to, we can write alpha divided by, this is our p, p minus 2 alpha, alpha plus beta plus gamma is p. Therefore, we can write alpha divided by p minus 2 alpha. Similarly, for the second one, beta divided by gamma plus alpha minus beta can be written as beta divided by p minus 2 beta, and the third one is gamma divided by alpha plus beta minus gamma can be written as gamma divided by p minus 2 gamma. Therefore, we have to form the equation whose roots are alpha divided by p minus 2 alpha, beta divided by p minus 2 beta and gamma divided by p minus 2 gamma. Here we use the transformation relation as y is equal to x divided by p minus 2x. From this we can write x as p into y divided by 2y plus 1. Using this value of x in the given equation, we will get the required equation as x cube, that is py divided by 2y plus 1 the whole cube minus p into x square, x is py divided by 2y plus 1 whole square plus q into x, that is py divided by 2y plus 1 minus r is equal to 0. That is r into 2y plus 1 whole cube, r into 2y plus 1 whole cube minus pq into 2y plus 1 whole square plus p cube y cube into 2y plus 1 minus p cube y cube is equal to 0, p cube y cube is equal to 0. That is p cube minus 4 p cube plus 8 r into y cube. Terms we combine all the terms having y cube, we will get p cube minus 4 p cube plus 8 r into y cube, plus next we combine all the terms having y square. Therefore, we will get p cube minus 4 p cube plus 12 r. From this we will get into y square plus the terms having y is 6 r minus p q into y plus r is equal to 0, which is the recurred equation whose roots are alpha divided by beta plus gamma minus alpha, beta divided by gamma plus alpha minus beta, and gamma divided by alpha plus beta minus gamma. Now, let me conclude this session. In this session, we discussed some transformation, general transformation of algebraic equations. Hope that you have understood the topic. Thank you for listening the class. Goodbye.